our next lesson is maintain kitchen tools, equipment, and working area.
This is still part of Lesson 1, Maintain Kitchen Tools and Equipment. Let us start. Cleaning and sanitizing. Cleaning and sanitizing procedures must be part of the standard operating procedures that make up your food safety program. Properly cleaned and sanitized surfaces allow harmful microorganisms to be transferred from one food to other foods. Cleaning is the process of removing food and other types of soil from a surface such as a dish, glass, or cutting board. Cleaning is done with a cleaning agent that removes food, soil, or other substances. The right cleaning agent must be selected because not all cleaning agents can be used on food contact surfaces. A food contact surface is the surface of equipment or utensil that food normally comes into contact. For example, glass cleaners, some metal cleaners, and most bathroom cleaners cannot be used because they might leave an unsafe residue on the food contact surface. The label should indicate if the product can be used on a food contact surface. The right cleaning agent must also be selected to make cleaning easy.
Thank you, Ma'am Donna. Let us now move on to the discussion of cleaning agents. Cleaning agents are divided into 4 categories. Detergents. Use detergents to routinely wash tableware, surfaces, and equipment. Detergents can penetrate soil quickly and soften it. Example, it includes dishwashing detergent and automatic dishwasher detergent. Solvent cleaners, used periodically on surfaces where grease has burned on. Solvent cleaners are often called degreasers. Acid cleaners, used periodically on mineral deposits and other soils that detergent cannot remove. These cleaners are often used to remove scale in ware washing machines and steam tables. Abrasive cleaners. Use these cleaners to remove heavy accumulation of soil that are difficult to remove with detergents. Some abrasive cleaners can also disinfect. Clean food contact surfaces that are used to prepare potentially hazardous foods as needed throughout the day but no less than every 4 hours. If they are not properly cleaned, food that comes into contact with these surfaces could become contaminated.
Thank you, Sir Jason. Now, let us move on to sanitizing. After knowing what is cleaning, let us now have sanitizing. Sanitizing is done using heat, radiation, or chemicals. Heat and chemicals are commonly used as methods for sanitizing in restaurants, while radiation rarely is. The item to be sanitized must first be washed properly before it can be sanitized thoroughly. Some chemical sanitizers, such as chlorine and iodine, react with food and soil and so will be less effective on a surface that has not been properly cleaned. Let us now have the sanitizing methods. The first one is heat. There are three methods of using heat to sanitize surfaces. The first one is steam, second hot water, and the third is hot air. Hot water is the most common method used in restaurants. If hot water is used in the third compartment of a three-compartment sink, it must be at least 171 degrees Fahrenheit or 77 degrees Celsius. If a high-temperature ware washing machine is used to sanitize cleaned dishes, the final sanitizing rinse must be at least 100 degrees Fahrenheit or 82 degrees Celsius. For stationary rock single-temperature machines, it must be at least 160 degrees Fahrenheit or 74 degrees Celsius. Cleaned items must be exposed to these temperatures for at least 30 seconds. The second sanitizing method is chemicals. Chemicals that are approved sanitizers are chlorine, iodine, and quaternary ammonium. Different factors influence the effectiveness of chemical sanitizers. Let us now have the three factors that must be considered when using chemical sanitizers. The first to consider when using chemical sanitizer is concentration. The presence of too little sanitizer will result in an inadequate reduction of harmful microorganisms, while too much can be toxic. The second to consider is temperature. Generally, chemical sanitizers work best in water that is between 55 degrees Fahrenheit or 13 degrees Celsius and 120 degrees Fahrenheit or 49 degrees Celsius. The third is contact time. This means how long the sanitizer will be used. In order for the sanitizer to kill harmful microorganisms, the cleaned item must be in contact with the sanitizer, either heat or approved chemical, for the recommended length of time. This is a must-have for restaurants. This is sanitizer testing. Every restaurant must have the appropriate testing kit to measure chemical sanitizer concentrations. To accurately test the strength of a sanitizing solution, one must first determine which chemical is being used. Is it chlorine, iodine, or quaternary ammonium? If you are going to use chlorine as sanitizer, you should use the testing kit for chlorine. If you're going to use iodine, then you should use the testing kit for iodine and for quaternary ammonium because test kits are not interchangeable. So check with your chemical supplier to be certain that you are using the correct kit. The appropriate test kits must be then used throughout the day to measure chemical sanitizer concentrations.
Thank you, Ma'am Marlene. Class, I will give you more information about sanitizers. Advantages and disadvantages of different chemical sanitizers. Chemical. Chlorine concentration. 50 ppm in water between 75 and 100 degrees Fahrenheit. 5 grams per liter of water. Contact time, 7 seconds. Advantage. Effective on a wide variety of bacteria. Highly effective. Not affected by hard water. Generally inexpensive. Disadvantage. Corrosive. Irritating to the skin, effectiveness, decreases with increasing pH of solution, deteriorates during storage and when exposed to light, dissipates rapidly, loses activity in the presence of organic matter. Chemical iodine concentration 12.5 to 25 ppm in water that is at least 75 degree Fahrenheit, 2.5 grams per liter. Contact time 30 seconds. Advantage: forms brown color that indicates strength, not affected by hard water, less irritating to the skin than in chlorine, and actively not lost rapidly in the presence of organic matter. Disadvantage: effectiveness decreases greatly with an increase in pH. Most active at pH 3.0, very low acting at pH 7.0. Should not be used in water that is at 120 degree Fahrenheit or hotter, and might discolor equipment and surfaces. Chemical quaternary ammonium compounds. Concentration up to 200 ppm in water that is at least 75 degree Fahrenheit. Contact time 30 seconds. Advantage: non-toxic, odorless, colorless, non-corrosive, non-irritating, stable to heat and relatively stable in the presence of organic matter, active over a wide pH range. Disadvantage: slow destruction of some microorganisms, not compatible with some detergents and hard water. Cleaning kitchen premises. Cleaning your kitchen regularly is important, not only to keep it looking its best, but also to remove all the germs and bacteria that accumulate regularly in the kitchen area. There are several surfaces around the kitchen, and by making a homemade versatile cleaning solution, you can easily clean most of the surfaces with one basic mixture of household ingredients that are probably already in your kitchen cupboards. Things you'll need: broom, cleaning rags, and bucket. Instructions: 1. Collect loose dust by sweeping the kitchen floor daily with a broom or sweeper and wiping down countertops, tables, and other surfaces with a cleaning rag. To remove sticky buildup, wipe with a damp cleaning rag and wipe a damp mop over your kitchen floor. 2. Mix 1 gallon warm water in a bucket with 1/2 cup white vinegar and 1 teaspoon dish soap. Dip your mop into the bucket, wring the mop out, and wipe across the kitchen floors. The diluted vinegar solution makes it safe for any kitchen floor surface while still strong enough to clean and disinfect. The dish soap assists in cutting through any food residue that may be on the kitchen floor. Let your floor air dry after cleaning. 3. Make an all-purpose cleaner in a spray bottle. Combine 3 cups warm water with 1/2 cup white vinegar and 1 teaspoon dish soap. 4. Spray this solution onto kitchen surfaces and wipe off with a damp cleaning rag. This works well on any type of kitchen surface, including cabinetry, sinks, tables, counters, and any other area that requires cleaning. 5. Fill a few bowls with about 1/2 cup each of baking soda. Place this around your kitchen to absorb odor and keep the kitchen smelling fresh. Open windows to let fresh air circulate, which is especially useful when cooking strong-smelling foods.